Now, in this video, we will going to discuss about the linear strain and the longitudinal strain. So, what is a linear strain? When a body is subjected to an axial or tensile or compressive load, there will be an axial deformation along the length of the body. Longitudinal or linear strain is defined as the ratio of length of axial deformation to original length of the body. So what does it mean? Suppose if you have a member of a rectangular member wherein you have the length is equal to L, subjected to an axial load, axial tensile load. Here P is the axial tensile load which is acting on the member. So initially the body will going to have the width B and depth thickness or T, which is T. It is ratio of length of axial deformation. So what is the deformation? So once you are subjected to an axial tensile load, the member will going to have the deformation along the length that will going to be an increase in length. But what happens to the lateral dimension? The lateral dimension of B and T is reduced to B minus delta B in width and T minus delta T in depth. So that is what we will be able to see here. It is also defined as the change in length per unit length in the direction of the applied load. So which is the direction of the applied load? The direction of the applied load is along the length of the member. Therefore, the deformation will going to take place along the length of the member with L plus delta L. So let L going to be the original length of the body, and delta L is the change in length or deformation in the length, and P is the axial load, which is either it can be tensile or compressive. In this particular case, we have taken the tensile. So what is the linear or longitudinal strain? The linear or longitudinal strain is nothing but the change in length by the original length of the member. So then what happens? What is change in length? Delta L by L. So what does it mean? So if you consider here, so that is delta L by L. Now we are going to take up what is the lateral strain. So which is the lateral strain we are talking about? The lateral strain is the one what we are talking about is B and T, which will going to be B minus delta B and T minus delta T. Now here, if you are considering the lateral strain, again we have the same sketch we have considered here, wherein in this case, since there is a deformation along the length of the member, that is the increase in length, so naturally the width and thickness or the width and depth will going to be reduced. When a body is subjected to an axial load, it undergoes deformation in the direction of load and perpendicular to the direction of load. So in the sense that it undergoes the deformation in the direction of load means along the direction of the load which is applied. So you are going to have, there is a deformation along the length. Perpendicular to the direction of load means it will going to be the lateral dimension. So what we are talking about in this particular view, initially it was B and T. Finally, it has, since it is the tensile load, therefore the lateral dimension will going to decrease. So that is the reason why we are taking B minus delta B and T minus delta T. Finally, the volume will going to remain the same. So when we are considering a rectangular block of length L, the width B and thickness T is subjected to an axial tensile load, which is shown in the figure. Due to this application of this load, the length of the bar will going to increase while the breadth and thickness will going to be decrease. If the load is compressive, then the length will going to be decreased and the area of cross section, that is width and thickness, will going to increase. So the strain in the direction of applied load is the longitudinal strain, or which is the linear strain. The strain at the right angles or perpendicular to the direction of applied load, then it becomes the lateral strain. So here let delta L will going to be the increase in length. How it will going to be the increase in length? That is the final length minus the original length. So what is the final length? L plus delta L is the final length minus the original length is L. Since LL will get cancelled, so therefore you are going to get delta L. Similarly, delta B is a decrease in width. So what is that? Original width minus a final width. So what is the original width? Original width is B minus the final width is minus of B minus delta B. So B minus B will go get cancels, and minus into minus is become plus delta B. So this will go to be the delta B. Similarly, delta T is the decrease in thickness. So same explanation what it holds good. That is initial thickness minus final thickness. So initial thickness is T minus final thickness is minus of T minus delta T. So when it is open this bracket, T minus T will going to get cancelled. Minus of minus becomes plus delta T. So that is equal to delta T. That is the decrease in thickness. What is L? L is the original length, B is the original width, and T is the original thickness. Now what happens? Now linear or longitudinal strain, which is what is that? Delta L by L. So delta L by L will be the lateral strain, which is epsilon again, which is change in lateral dimension to the original lateral dimension. So what is going to be? Delta B by B or delta T by T. So this is how you will be able to explain the lateral strain and the longitudinal strain. Now we are going to take up the one is another important thing is the Poisson's ratio. So what is the Poisson's ratio? The ratio of lateral strain to the longitudinal strain is constant for a given material when the material is stressed within the elastic limit. And this ratio is called the Poisson's ratio. So that is the ratio of lateral strain by the longitudinal strain, which is a constant for a given material. So the material is identified by the Poisson's ratio also, which is denoted by 1 by m or mu or nu. So what is the Poisson's ratio? 1 by m will be equal to the ratio of lateral dimension to the lateral strain by the longitudinal strain. So what is that? So lateral strain is delta B by B, or lateral strain is epsilon lateral by epsilon longitudinal. So what is the volumetric strain? The ratio of change in volume to the original volume of the body is known as the volumetric strain. Now we are coming into the volume, total volume. So that is a volumetric strain epsilon V will be equal to what is the change in volume by the original volume, which is delta V by V. Suppose if you are considering a rectangular bar of length L, width B and thickness T, which is subjected to an axial tensile load, what will going to be the original volume? The original volume is nothing but length into width into thickness. So L into B into T. So if you are considering the change in volume delta V, which will be final volume minus the original volume. So what is final volume? L into B into T minus plus what is that? Final volume, that is L into B into T plus B into T into delta L plus minus of L into T into delta B minus L into B into delta T. So here this will going to be minus L into B into T. So neglecting the product of these values, what happens? We will going to get the value of delta V, which will be equal to B into T into delta L minus L into T into delta B and then L into B into delta T. Therefore, what is the volumetric strain? Epsilon V will be equal to delta V by V. So we know that B into T into delta L minus L into T into delta B minus L into B into delta T divided by L into B into T. So that is will be equal to delta L by L minus delta B by B minus delta T by T. So this is how you will be able to get this answer. Why this? In this case, in the original, in the final volume, what we are talking about is plus here. So that is basically because since it is the lateral longitudinal strain is along the length, so it will be plus here, and the lateral dimensions are delta B, delta T, and then this is the final volume, and this is the original volume is L into B into T. So that is the reason why you will be able to get this value as B into T into delta L minus L into T into delta B minus L into B into delta T. So this is how you will be able to get this value of volumetric strain. So what is that Poisson's ratio? Poisson's ratio is nothing but 1 by m, which will be equal to lateral strain by the longitudinal strain. So what is lateral strain? 1 by m into longitudinal strain. So what is that is lateral strain is delta b by b or delta t by t. So that will be equal to 1 by m into delta L, or delta L by L is the longitudinal strain, and delta b by b or delta t by t is the lateral strain. So therefore epsilon v will be equal to delta L by L minus 1 by m into delta L by L minus 1 by m into delta L by L. So that will be equal to delta L by L into 1 minus of 1 by m into 2. So if you are on simplification, you will going to get it as delta L by L is into 1 minus 2 by m. So this is how you will be. Therefore, the volumetric strain epsilon delta V by V, which is the longitudinal strain into 1 minus 2 by m, which is delta L by L into 1 minus 2 by m. Similarly, epsilon V will be equal to delta V by V, which is delta L by L into 1 minus 2 by m. So epsilon delta L by L is what? It is epsilon into 1 minus 2 by m, where epsilon is the longitudinal strain and where epsilon will going to be the longitudinal strain. So this is how you will be able to discuss about the volumetric strain, the Poisson's ratio, and the lateral and the linear strain. Thank you.